My name is Malcolm Bisby. I've been interested in industrial history for many years, and as a personal initiative, I've done extensive research into the story of the finding of a high-grade form of ironstone in the Rosedale Valley, and found it such a fascinating story. I felt it would be worth sharing with others, and I've made a series of 4 DVDs from talks I've given at village halls. Talk number 1 sets the background to the story of the exploitation of this amazing find of ironstone and the means of getting that transported from the Rosedale Valley across the North York Moors. Part 1 deals with the construction of the railway, the initial part of the construction from Battersby Junction along the face of the Cleveland Hill escarpment, and then the achievement of an incline to bring the standard gauge railway up onto the North Yorkshire moors for onward transport to the blast furnaces of Consett and Ferry Hill at County Durham. The thing that fascinated me about the Rosedale story is that it has everything in it for a Victorian drama documentary. It's got cheating, discoveries of great riches, made some people extremely wealthy. There was even a murder thrown in, a ghastly murder, and it's really got everything in it. Tragedy, huge achievement. So it is very lengthy to tell you the whole story. I think it's worth telling. But the thing is, it's local, it's here. It was of national importance, was this. It's been sort of forgotten over the years, but it actually was a very important part of the story of Britain's industrialisation. Today I really want to set the sort of background to this. You know, the date is 1860 when the railway first started to be constructed to exploit the findings in the Rosedale Valley. In those years, of course, we didn't have roads as we know them. I mean, Rosedale was a remote place in relative terms in those days. Still, some people would argue it still is. But imagine the logistics of putting a standard gauge railway across the North York moors. No mechanical aids, just pick and shovel, horsepower, and a bit of gunpowder, black powder as they called it, for blasting purposes. And it was achieved in record time. And it was achieved in the time when we had winters that were really serious winters. And the navvies who constructed that railway and worked right through the winters. I mean, the conditions were just unbelievable. So the construction of the railway in itself was an achievement. But then, of course, we had the extraction of the ironstone. The ironstone that was discovered was unique in British mining history. You know, its like hasn't been found anywhere else. Geologists are still trying to explain how it came to be in Rosedale. There are all sorts of theories, but nobody has yet come up with a definitive answer. The early figures that were quoted back in Victorian times, on the time of discovery, were up to 60% iron content. Now, we've had samples analysed by modern methods, and I can tell you it's over 71% iron content. It's absolutely phenomenal, unheard of. The average iron content of Cleveland ironstone, which was the ferrous oxide, a poorer form of ironstone, but there was a lot of it, and it was easy to get, relatively easy to get, was only averaging somewhere around about 30%. I mean, the Eston seam was probably the best, main seam quality, which probably averaged a bit higher, possibly 35, but the average across Cleveland was somewhere around about 30%. And you compare that with Rosedale, with ironstone that was achieving 71%, it fetched double the price, as you can understand. And the railway was established. Of course, the only way to carry this out of Rosedale was with a standard gauge railway. They tried with horse and carts. They had up to 8 horses pulling a cart full of ironstone 10 miles all the way to a railhead. The nearest railhead was at Pickering. And of course, that didn't last very long. I mean, the roads, such as they were in no condition to take loads like that, and were churned up, and it became impossible. Something like 4,000 tonnes was shifted to Pickering Station over a 2 or 3 year period before the railway was finally established. And at peak, the railway was moving something like 1,600 tonnes a day across the moor. So this talk is essentially about getting on with the construction of the railway, an amazing achievement in itself. So for the railway buffs amongst you, it'll satisfy you. But just very briefly to explain that geology in that period was only really just getting established. Understanding, the strata, the earth strata, things like the main seam and the pecten seam and all the rest of it. Geologists were just really getting into the science of this. So it was a bit hit and miss. However, Britain by this time is heading to be a superpower. I mean, Britain by the 1880s was a world superpower. We could afford the world's largest navy. And the reason we were a superpower, because we were a very inventive nation. We were technically way in advance. The Cleveland blast furnace practice was renowned throughout the world and copied. We had the best designs of blast furnaces. We were just technically way ahead of the rest of the world. So this is the background that we're setting the Rosedale story against. And this area, the Middlesbrough sort of district, the Cleveland district, with its blast furnaces and output and ironstone products, was providing 38% of the UK's total iron production. Britain, in the late 1870s, was producing something like 50% of the world's needs in iron production. I mean, these figures are just astonishing. And Rosedale featured in this to the extent that we're talking sort of 19% of this country's contribution to exports were from this area, from the Rosedale area. So it was a very important area, and it had this unique find of ironstone. And then in this mix, of course, you've got the characters, the cheats, the fraudsters, and all the rest, which you'll hear all about. Anyway, we'll get started. The coastal scene was really the start of ironstone exploitation in this area. The main seam outcropped at various points on the coastline, particularly around the Stays area. And the action of the sea, of course, you got lumps of the main seam breaking off, forming sort of boulders. And these were simply picked up off the beach and floated off in flat-bottom craft. And this ironstone was sent off to Jarrow, the blast furnaces. There were none around this area. At the 1830s, of course, they were all up in the Durham area mainly. The ironstone industry really almost, you could say, started at beach level. So here's a very good friend of mine, sadly deceased now, John Owen, around the Stays area, and we can see here where there's a bed of ironstone exposed, and this is actually main seam ironstone. It's not normally that colour, it's just, it's been exposed to the atmosphere and seawater. A freshly dug up chipped off piece of main seam ironstone is a greeny grey in colour. So here we can see another part of the main seam. It would be deeper than that because it would go further down. Now, once they started to realise, if we dig into the cliffs, we don't need to wait for the tide to uncover it. And so here we see, a bit dark, but we can see there's a drift entrance here. And you can imagine tidal effects it meant it was a very limited time that you could spend in there. It tended to be a summertime occupation. The winter storms, you wouldn't want miners in there hacking out ironstone. So its production was extremely limited. The first real success into the main seam came in 1848, when the main seam at Skidding Grove was tackled, and that was out of the sort of tidal limitations. It wasn't really satisfactory at the Skidding Grove end, and they actually then drifted in from Loftus into the same seam. It was still the main seam, but that's when things really started to get cracking. And then, of course, there was the famous find of the Eston seam by John Vaughan and Marley in 1850, and that really kicked off the boom then. Then things really started to move. And then in 1853, the discovery of this incredible ironstone in Rosedale, and then that set in train the whole business of how do we get this stuff out of the valley. So there were myriads of, at that time, 1840s, 1850s, there were railway companies being formed almost overnight. Some of these railway companies had a line length little as 8 miles, and it formed, it was a railway company. So you had dozens and dozens of these applying for parliamentary approval for a line from, Newcastle to Almouth or somewhere like that. And this was one of them, the North Yorkshire and Cleveland Railway Company. And they all had fancy logos, and you see on that logo they boasted that they were involved with shipping and industry and agriculture and all the rest of it. But really what they were interested in was the mineral traffic. They weren't interested in passengers, they were interested in the mineral traffic. And it was judged by this time, things were starting to move in this area. There was Gromont, there were the Eston finds, and so this railway judged that it would pay them to construct a line from Picton, what we now know as the East Coast Line, Picton Junction, right across to Gromont. And on the way, there'd be numerous exploitations of ironstone, because everybody thought that the whole of North Yorkshire, well, Cleveland certainly, was sitting on a solid bed of ironstone, and wherever you dug, you'd find it. So it was reckoned that Ingleby and Kildale, Commondale, Danby, Castleton, they were all there for the asking, and the mineral traffic movement would be very profitable for this railway. So anyway, they're in the process of constructing this line, and it just so happened that at this time, after the discovery of the Rosedale Railway, it was realised that they could link up the Rosedale traffic with this particular railway. So this railway applied to Parliament, an Act of Parliament, to build a line across from what we know now as Battersby Junction to the west side of the Rosedale Valley, to a place we know now as Bank Top. These railway companies, if there was any competition, if they could find a way of sabotaging them. So if two companies were after this route, if one could object when an application was made to Parliament for an act to be passed in favour of this company, they would object. They'd do anything to block their competitors. But because this was a small company, it wasn't seen as a threat by others. And the application to Parliament went through, and they got permission to build a line across the moor top to Rosedale. Now, sitting in the wings was the North Eastern Railway Company, which was up and coming, a very, very dynamic railway company, which became the dominant railway company in this area. And they just sort of waited their chance. When it suited them, they made an offer for the North Yorkshire and Cleveland Railway, and the offer was accepted. It was a very tempting offer, and the North Yorkshire and Cleveland Railway was effectively absorbed into the North Eastern Railway, which thereby got the Parliamentary Act approval for the building of the line to Rosedale. Yeah. Now, here we see the Act of Parliament that allowed the North Eastern Railway Company to effectively gobble up the North Yorkshire and Cleveland Railway in August 1859. And one of the driving forces on the North Eastern Railway Company was this chap, George Lehman. He was vice chairman at the time. He was in a powerful position, and he was one of the arch conspirators to cheat the other shareholders out of their rightful share, including the two men who discovered the Rosedale ironstone, and they succeeded. And it ended up with three of them virtually owning the whole lock, stock and barrel, and made a fortune. Now, the North Eastern Railway really sort of came out almost out of the wreckage of the York and North Midland Railway. And this was the famous George Hudson, who, the story of him was that he was simply a draper. He had a draper's shop in York. An uncle left him a fortune in those days, and he invested in railway shares, made another fortune, and got involved with railways. And actually, he was a great organiser, and he made that famous comment, "All lines must come to York," he said. And he set about making sure they did. And he bought up little railway companies, and he organised. And he was really almost the sort of architect of the modern railway system. He had a lot of good in going for him. He was accused of share fiddling, really inflating share prices and causing, a bit of a scandal. Others were involved. He carried the can, unfortunately, and ended up accused of the crime and carrying the can, and ended up living in France, I think, as a sort of banished from the country almost. So, the scheme is setting in hand to start the build of the Rosedale Branch Railway. Plans were ready by September 1859, and in January 1860 construction began. North Eastern Railway calculated 40,000 to build the line and the infrastructure. The first successful quote was for £19,500 by Stewart and Scott. They got started in January 1860, but unfortunately they realised they'd bitten off more than they could chew, and there was no way they were going to build a railway across the moor for that price. So they reneged on their contract. So the next successful bidder, a company from Newcastle on Tyne, Cale and Towns, Richard Cale and Thomas Towns, and they bid £24,500, which was accepted by the North Eastern Railway Company, and construction began. These are the statistics. The line length, that's across the moor top, 11 3/4 miles. There was another 2.5 miles to the foot of the incline, and then the incline itself was approximately a mile. The moor height was 600 feet higher than the Cleveland Plain, but above sea level it was 1,370 feet. I think it was only the Weardale Railway that was a little bit higher than the Rosedale Railway. It was amongst the highest in England. Now, I mentioned the severe winters, and they were severe. It did cause extra expense to the contractors. They put in an extra claim for £4,000, but the NER would only stump up another £2,000 to compensate them for the problems they'd had in the winter periods. And their winters were on par with, our 1963s and 47s. I mean, quite unbelievable. So this is the route. This is the so-called, it was called the Great Northern Line at the time, that the East Coast Main Line for us. And the North Yorkshire and Cleveland Railway were planning this route across here to Gromont. But at Ingleby, it was found that near Old Battersby village, it would be a suitable area to produce a marshalling area and link up with what had been planned for the Ingleby mine as a private railway route to move the ironstone from the Ingleby mine, which we'll see in a moment, to a pickup point or a railhead, and this was going to be at what we now know as Battersby, but didn't have a name at all then. It was just referred to as Ingleby, but it wasn't at Ingleby stations. So the plan is then to build an incline and come up onto the moor, cross the North York Moors and come into the Rosedale Valley and exploit the first finds which were down here where the magnetic ironstone deposits were found, and then later on to go around to the east side of the valley and exploit ironstone there, which wasn't the same stuff. It was of low quality, but it was still good quality stuff. This is a sketch, well, a drawing 1913 of Battersby Junction, which by this time had been named Battersby Junction. And the railway got into operation by March 1861. Battersby Junction was a key to handling the traffic, the ironstone traffic, but it didn't have any cottages for the railwaymen until 1872. So for a period of, nearly 11 years, that junction operated without any cottages. Eventually, these cottages were built, 37 in total, and by this time the traffic was massive. The marshalling area is this area here, and in 1878 they built an engine shed, and the complement of steam, to give you some idea of the traffic, the permanent complement of steam engines based at Battersby, this is just for hauling ironstone traffic up to Ferry Hill and Concert, because that's where it went. 9 engines permanently allocated to Battersby Junction, and an engine shed was built about 1878, and it was a 3-road engine shed, and it had a capacity for holding 8 locomotives. On the moor, established on the moor, permanent establishment, were 5 steam engines at peak once the east side mines had opened. That gives you some idea of the scale of the operation. And here we see a photograph taken in 1955. These are the cottages at Battersby Junction. I mean, the railway closed in 1929, and yet rails are still in place, and it's just as though it's there to be operated whenever, and that's the scene today. Finally, the rails have been lifted. Now, the cottages that you see are now all privately owned. In 1971, British Rail Board decided they were going to sell all these cottages at Battersby, and the ones that they still had control of were numbered about 30. 1 or 2 had been sold off individually, but 30 were left. And they were sold to a London property company, Zelligrate, in 1971, with 7 acres of land, 30 of these cottages for £41,000. I mean, they made some profit at that. So these have all been sold off privately now. They're all privately owned. This was Battersby Junction in 1910, and you can see how well established it is. Station house, extensive railway network, and we can't see it, but there were way cabins and the marshalling area behind on the right. And that's the scene today. A few changes. There's all the signal gantries have gone, of course, and very limited service now. 8 movements in total a day on the Middlesbrough to Whitby section. And this was a photograph taken from the J.W. Armstrong collection in 1951. And again, it shows you that the Rosedale marshalling area is really still the same. The crossroad line, the ironstone wagons would be marshalled up into sets and on this side, and then eventually, once everything had been weighed up, it would join the main line and it would steam off to join the coast main line, the Great Northern as it was in those days, steaming up to the blast furnaces at Ferry Hill and Consett. And that's the scene today. And we can still see the water crane still here, and there are serious plans being mooted to restore that, put it back into effect, because there's quite a bit of steam traffic now at Battersby. These are steam trains that come up to join the North York Moors Heritage Railway, and it's a fairly steady flow of traffic in steam terms. And the water tower still exists. The massive iron tank is still there. The scrap men have been round a few times, but the farmer has refused to sell. And of course, I mentioned the steam trains that still call at Battersby. This is Blue Peter on one of the visits to the North York Moors Railway. But this was the type of steam locomotive that was employed on the Rosedale traffic. It was a William Boots designed 060, and I want you particularly to notice the cab. I mean, there was no thought given to train crews in those days. Can you imagine? It's the depths of winter, it's driving rain, sleet, snow, whatever, and that's the shelter for the crew. Barely covers their head. Now, that was fairly standard, of course, across the railway network, but these engines were employed on the Rosedale traffic, and the ones on the moor had to be specially adapted because I mentioned the severe winters, and because of the single line route that they operated on across the moor, 50% of the time that the locomotives were operating, they were operating in reverse. So you can imagine this locomotive going backwards against the driving rain and everything. There's no protection for the crew at all when it's tender first. And the conditions were so severe that the crews literally wouldn't have survived. So they had to adapt, modify, and they built what they called a tender screen. And this was unique to the Rosedale traffic. It was a sign that the conditions on which the line operated in winter was so severe that they had to have special protection. And here we see it, protection guard on the tender, and then there was a tarpaulin that was slung over the top. If the weather was seriously bad, they could cover the top. But the point was that when they were going in reverse against the wind or the rain or whatever, at least the crew had some protection. And as I mentioned, 50% of the time they were operating tender first. So here's the 3-road engine shed at Battersby. It lasted until about 1965, and then for some inexplicable reason, British Rail demolished it. It would have made a fantastic warehouse, and I can't understand. It was a massive dimensions, and it was used. Over the years it was used as a shooting range. It was used in World War I to store Pullman carriages when the war stopped all that luxurious railway travel. It was used in the mid-war years, for storage of fertilizers and all sorts of things. And then in 1965, for some reason, they demolished it. This photograph, undated, but it still shows the feed line in from the bottom of the incline into the Battersby area. There we see the 3-road engine shed, and the marshalling area is down here somewhere. So this is the traffic coming down from the moor, feeding down on this feeder line to the marshalling area to be marshalled up for sending off to concert. And that's the scene today. Now this is the crossing gatekeeper's house, or it's a house where a crossing gatekeeper resided. The railway passed on this side, and so the gatekeeper, because we were crossing gates, it was a public road, so the crossing gatekeeper operated these gates, and a railway employee lived on the other side. Here we see crossing the highway between Ingleby and Old Battersby village. The sign there says Ingleby Junction. This is the North Yorkshire County Council signage, but the railway actually had dropped the word junction in 1893, but the council have kept it going. So it's still referred to as Battersby Junction, but the railway long since did away with that. So we're now crossing the fields, heading to the bottom of the escarpment to approach the incline to get us up onto the moor top. This property on the left, we had another gatekeeper here, operating gates on this busy track, and it's named Poultry House Crossing, a strange name. And I climbed up, can't do that these days, and my legs are rubbish. But in those days, I was able to climb on the hillside to give you a bird's eye view. So we've come across from the Ingleby Junction, we've come across the fields here. This is Poultry House Crossing, and this route here was a very busy highway. This was the Rudland Rig route from Kirby Moorside, Bransdale, to places like Stokesley and even Middlesbrough. And this was a sort of like drovers' road, horse-drawn traffic, travellers, walkers, very busy route. So it had to have crossing gates at this point here. Remember, once the railway got cracking, once the ironstone traffic got going, the train traffic across here was very, very regular, so you had to have crossing gates. This is the main highway, and the highway is up here. I mean, God help those who were caught in snowstorms up there and walking from Kirby Moorside to Stokesley, coming over the top here, and then descend down the hill and down here to Ingleby or Stokesley or wherever. And here we see again the route of the railway. So we're now crossing over, and we're on to the original track bed, Poultry House Crossing back there. And on the way, we're passing inclines that were built to handle the Ingleby Freestone. Sandstone was a very good quality sandstone, and there were quarries all the way along the top. And this quarry stone was in big demand for, remember, in that period, they were building stations and bridges, harbours, wharves, etc., etc. So there was a real demand for good quality sandstone, freestone as they called it. And so there was a heavy traffic of that. And that is not really fully taken into account. Once the railway got established, it was a godsend for these quarries. In fact, it enabled them to expand, because for the first time they got the right form of transport for the quarry stone. And we have no figures to tell us how much was transported on the Rosedale Railway, but we know that there were loading docks across the moors for freestone, taking advantage of the Rosedale Railway. And it's quite possible we're talking a minimum of 500,000 tonnes of freestone moved by the railway, which is not mentioned in the books, and yet it was here. And this was right next to the railway line. And in fact, they had a loading dock. They had a loading dock near here to load the stone onto railway wagons. So it's something that's not taken into account when figures are quoted for the traffic on the Rosedale Railway. And here we are. Imagine you're a contractor, you've agreed to build a railway line across the moors, and you've shown the escarpment that you've got to get up. Now, this is nearly a mile long. It's 1 in 5 at its steepest, which is up here. You've got to get a standard gauge railway established up there, which on it by itself is a huge task. But then somehow you've got to get wagons up and down. I mean, this is 1860. I mean, if you took a modern contractor there and showed him what he'd just agreed to build, he'd probably turn white, So it was a heck of a feature and a feat. And that height from the Cleveland Plain, this is the Cleveland Plain, to the top there is 600 feet. And at the top, you're 1,370 feet above sea level. So that's the task, but it's pick and shovel. And it's 1860, and there are no proper roads. So, you can see the achievement and the scale of the challenge that they face. Here we're at the foot of the incline. The forestry in the meantime, I mean, the whole of the hillside in the operational days was completely bare. But in the intervening years, the forestry planted trees. So here we are at the foot of the incline. And this is what it looked like in about 1903. So we've got a way cabin here, and you can see the pretty bare hillside. Just a few trees, but nothing much at all. These brave or foolhardy people here, and they're dressed in Edwardian gear, so that gives you the era. These are empty wagons, and they're waiting for them to be hauled up to the top. They're taking a big risk. The company actually banned people riding on the wagons, but people did it. So, walking up the incline, we're about halfway now, and you're getting some idea of what it's like. And we're nearing the top. The rock here would almost certainly have been part blasted. They had to use gunpowder. Dynamite wasn't invented till, I think, 1871. Well, it wasn't really available anyway till 1871. Dynamite had 8 times the power of gunpowder, and it was much more convenient because gas could be wrapped in waterproof wrapping. So wet days didn't matter. You could still set dynamite charges, and it didn't matter if it was snowing or raining. Gunpowder was different. You had to keep this stuff dry. So all these things were a handicap to the construction work. Nevertheless, they've hacked their way through this rock face. Now, strangely, on the left, and you have to look very carefully, but just off the picture here, there's a strange carving which has intrigued people. It's been written about and talked about, and it's the man with the pigeon. And the speculation is it was taking the mickey out of a foreman or somebody who was a pigeon fancier. It certainly dates it because it's the stovepipe hat. And this is my hero, Isambard Kingdom Brunel, the brilliant engineer. And this was the most famous photograph ever taken, in my view, of Isambard Kingdom Brunel posing with the anchor chains of the Great Eastern that he was building. And here we have the stovepipe hat, which virtually dates it to the 1850s, 60s. The pigeon bit is interesting. Now, it could be he was a pigeon fancier and simply that's all it was. There is another possibility. Remember, the date. It's 1860, 61, whatever. Communication's difficult. The telegraph's long been invented and is available. And of course, there's Ingleby Station, a few miles away. But if you're out on the moors and you're running out of supplies, your base is Newcastle. The contractors were from Newcastle on Tyne. And you want more supplies of whatever, rail or screws or gunpowder or whatever, the easiest way is send a pigeon. It's the quickest way. Newcastle, the pigeon would do it in just over an hour with its little message tied to its leg, and the message gets through and a shipment is sent down to Ingleby Station. It's just possible. I mean, God, we used them in World War I and II for more serious matters, so that is a possibility. The locals referred to him as Kruger. That dates it again. Kruger was the leader of the South African Boers who revolted, of course. We had the Boer War of 1898 or whatever it was. So Kruger was their leader, wore a stovepipe hat. So the locals referred to him as Kruger. We've almost reached the top of the incline. We're now having aerial views of the countryside. This is the scene that you would have seen in the operational days. This is known as the three-rail system. I won't go into the intricacies of it, simply to say that loaded wagons came down the centre, and these were known as kips. These humps were known as kips for some strange reason. Kips are mentioned in ironstone mining operations, and each group seemed to have their own pet way of describing things. We would have called these humps, and these are simply to receive the empty wagons on either side of the loaded wagons that are coming down the centre. Empty wagons come up either one of those humps and then run down the other side to be marshalled up for a rake of empties to be taken to the ironstone mine. And here we see the top of the incline, the cottages. There were a total of 4 cottages at the top. And this interesting piece of rail, a piece of ordinary rail, hinged, and it's pivoted so that it's just off centre, so it's unbalanced. It's a rocking bar, really. So what happens is, as the wagons come over the top, their axles depress this down. It's just balanced. It rocks down, and the axle presses it and clears it and moves on. We're on the hump here. That's the route for the loaded wagons. This is the hump. So once the wagon has cleared that rocking bar, it rocks back. So now, if the wagon runs back, that locks against the axle and stops it running back. Now, I had to do that because the wind at the top there, remember we're at 1,370 feet, it was nicknamed Siberia up there, and the wind force could be so terrific, it's actually been known to blow wagons back over the hump and down the, imagine what chaos that would cause. So this was a safety device, if you like. Here we see these are the humps, and this is the centre line for the loaded wagons. The brake drum house is there, and this was the marshalling area to make up into sets, a maximum of 4, around about a total weight on descent of about 60 tonnes. That's the weight of the wagons plus the contents, about 60 tonnes. It could be up to 4 wagons, 3 or 4 loaded wagons. The empties that were pulled up needn't necessarily be empty. It could be coal supplies, could be farmers' supplies, fertiliser and stuff like that. They had farmers' sidings on the railway that supplied agricultural goods to the farmers on the route. Also, of course, spare rail and sleepers and things like that. The so-called empties ascending weren't supposed to exceed 25 tonnes, and the descending wagons weren't supposed to exceed more than 60 tonnes. Of course, it was a self-acting gravity system, so the traffic always had to be heavier going down than for it to work. And the speed was controlled by massive drum brakes, well, van brakes really we should call them. The descent speed around about 30 miles an hour. I mean, that's quite fast. And it had to be controlled, obviously. The descent time around about 3 minutes. The turnaround, the total turnaround time from uncoupling the wagons at the bottom and rehooking onto, empties and organising the next download and making up a set at the top. Because, of course, you always had to have, a proper set descending and ascending. Turnaround time was about 10 minutes, which is pretty good, really. But it had to be at 1,600 tonnes a day, with a limit of 60 tonnes descending. You had to move pretty quick. And they did work through the night. Well, in the very busy times, it certainly was nighttime working. And in winter time, of course, there were paraffin flare lamps up the incline. But the weather conditions often, at 1,370 feet, you could get clouds forming. Halfway down there'd be clouds forming, mist and fog and snow and goodness knows what. So the brakemen in the cabins didn't have sight often of the wagons when they were ascending and descending. And so they had a treadle system that when the wagons reached a certain point, it rang a bell in the cabin, so they knew whereabouts the wagons were on the incline, because they couldn't see them for the fog or the snow, blizzards or whatever it was. And that's how they operated in nighttime or inclement conditions. So here we see there's a rake of trucks. Two of them are the metal wagons, the so-called hopper trucks, and a couple of wooden-sided wagons. So that is the maximum load that they could have on descent. And here's another view. This is a rear view of the set. Just while we're at the top of this escarpment, I'll mention the so-called Ingleby Manor ironstone mine. This is a sale map of the Ingleby estate. I think it was 1950. The Ingleby Manor estate was sold, and maps were prepared for potential buyers, and I managed to get hold of a copy. This is the incline that we've just seen, the new incline that was built, but there had been an original incline, and it was this one here, and this was to allow ironstone from the Ingleby, Freestone and Ironstone Mining Company's operation at the top of the incline to descend down and be loaded into wagons at the bottom here, and then there was a link line that took it all the way up through to Battersby Junction. And we can just see a trace of this as it existed many years ago. I think this was taken, I think it was 94 or earlier than that. I didn't take it, it's a friend of mine took it. There was a loading bridge arrangement at the bottom, so this incline came levelled out onto a loading bridge, which I'm afraid is a bit on the dull side. And the remnants are still there, that stonework is still there. And what would happen is the tubs of ironstone came down on a narrow gauge tramway, and the tubs of ironstone would either be tipped into chutes, and there'd be railway wagons standing here on a standard gauge line here, and the ironstone was either tipped into metal chutes and down into the wagons, or it went over a loading bridge and it was released vertically into the wagon. This is how they loaded. This is how they were operated on Farndale. Here we see at the 1,200 foot level, 1,200 feet above sea level, this is the mining drift into the Ingleby Manor seam. Now they were mining the very problematical Ellerbeck seam. The Ellerbeck ironstone seam is at the very top of all the ironstone seams. There are about 6 seams of ironstone of various thicknesses and depths. The Ellerbeck is the top one. When it's good, it can be very good, and when it's bad, it's absolute rubbish. And the trouble is with the Ellerbeck seam, you can be mining fine and getting, ironstone with a 40% iron content, and then in 2 yards, it's total rubbish, absolute rubbish, and it might be total rubbish for the next, 500 yards. It was so problematical, and it had an on-off life of about 6 years, but it was never going to be successful. And here we see a close-up. I'm sorry it's not particularly bright, but you can see a bit of a tram rail there, obviously borrowed from the inside the mine. And unfortunately, it's been bricked up. You can only enter 2 or 3 feet, and then you're up against a cemented wall here. So you can't go exploring, unfortunately. But this is where the ironstone was extracted from the Ellerbeck seam for the Ingleby Manor estate. And this was the first one to kick off. So this is the drawing of the engineer who was the man responsible for the incline. And in 1871, he gave a lecture to the Newcastle Mechanical Institute members, and he lectured specifically about the Rosedale Railway and the incline in particular. These were the illustrations that he used to illustrate the incline and the operation at the top. So here we see how the system worked. These so-called brake drums were cast iron. They were segmented, built up in segments. These things weighed about 60 tons. They were 14 feet in diameter, 2 of them. And of course, they took them up in sections and bolted them together. Simply dragging these things up must have been a heck of an operation. Remember, there's nothing to help them other than horses. Once they got this constructed and it was operational, things were easy after that. But up to this point, it was so difficult. So, as one drum unwinds its cable, the other drum is winding in. So it's just simply the way they operate the wind on the cable on the drums. Automatically, as one unwinds, the other's winding in. And the loaded trucks, of course, went through the centre, and the braking system were band brakes. So we had the band brakes operating onto the top of the rotating iron drum. They were really the old-fashioned motor car drum brakes, where the pads operated on top of the drum rather than at the side. Braking force was applied by ship's capstan-type wheels in these brake cabins. 2 men operated them, and with the gearing system that they had a mechanical advantage of something like 250 to 1. So if 2 men are putting their weight onto this big capstan wheel, which of course had again a mechanical advantage because of its diameter, and that force is multiplied, that force is then applied through a crank system to these band brakes, and the drum is arrested or slowed down. Now, unfortunately, in the early days, and this applied to railway wagons as well, they were wooden brake blocks, and carriages, of course, they were all wooden brake blocks. Asbestos pads hadn't been designed. And of course, frictional heat meant that they could seriously smoulder and burn. And in, I think it was June 1869, and these brake pads caught fire. And the pads set fire to the building structure, which had wooden cladding. And it stopped the job. I mean, the brake drum house was seriously damaged. And that, of course, is the choke point. If that breaks down, then everything stops. The output from the mines, they can only store a certain amount of stone before they run out of space. So then the miners become unemployed, the railwaymen become unemployed, and there's no social benefits, of course, in those days. So it's a serious business. And this was out of commission for a month. And that was a devastating economic situation for the railway. So they were desperate, and they did experiments. And this engineer explains to this audience in Newcastle in 1871 the experiments they did. And they experimented on the Stanley Incline in County Durham with different materials, and they settled on iron plates, iron brake pads. That's what it amounted to. And it was successful, and it actually worked. So believe it or not, you've got a rotating iron drum, and you've got an iron brake pad, and you clamp one on top of the other. And people would think, well, that can't be right. You wear the drum away, or and it won't work. It'll slide or whatever. It did. It was perfect. And also, because they were iron, they acted as a heat sink. So the frictional heat that built up was sort of dissipated, drained away into the iron pads rather than building up in a wooden pad and catching fire. Now the audience in Newcastle, I've got the report. The audience in Newcastle didn't believe it. They said it's impossible. You can't be right, And this chap said, we are, and it's working perfectly. And it worked perfectly to the end of its days. And railway wagons then started to copy the same idea. They changed from wooden blocks to iron blocks, iron brake pads, whatever you want to call them. But it was a panic development. I mean, they were desperate to get this thing up and running. As a consequence, they extended the drum brake house, they extended it and built a spares to 18 foot, not 14 foot, 18 foot drums, and put them at the back as spares. They were never used. They never needed to use them. From then on, everything worked highly satisfactorily. Cables broke from time to time, but other than that, it worked fine. So this is all featured in this particular Rosedale Incline. And again, it was a national first. Engineers came from far and wide to look at the Ingleby Incline. It was quite a technical sort of breakthrough. These are the band brakes. They were in sections. It wasn't a complete piece like that. It was made up in sections. And this was the way it was fitted together. You have to study this, but it's quite clever actually when you work it out. So these are the iron blocks. Sorry, those are the iron blocks that work on the drum. Right, and on this photograph, you can see the different roof line. This is the first original building, and you can see here where they've extended at the back to accommodate the two new 18-foot cast iron brake drums. When cables broke, of course, it was serious, total destruction. They had a means by where they could divert some of the wagons when a cable broke, if they were quick, and they had to be very quick. They could divert them into the hillside, and then they'd roll back and be saved. But if they were on the outside track of the escarpment, then they were launched into space. I mean, literally launched into space. And it was total destruction. They just went, plummeting down. And the cable broke. I mean, line speed 30 miles an hour. By the time the wagons reached the bottom, it was 300 miles an hour. And here we see an incident in 1903. They were lowering a painter's van And one of the painters actually wanted to ride in it. I bet he thanked his cotton socks that he didn't. The cable broke and the van ran out of control, got smashed to smithereens at the bottom. But the cable whipped back, and it whipped back to the point where it lashed. It came whipping through and smashed all the cladding at the back here. And there was a bit of a recoil as well here with smashed wagons. And the drums themselves were okay, but of course the cladding was all damaged. And this photograph just shows the danger if you're in the vicinity of a whiplash cable. I mean, it cut you in two. There's no record of any fatalities, but there is a case of one man losing his a cable caught him on his thigh and severed his leg with the hauling cable. And here we see there's been a standing locomotive at the bottom with a set of wagons, and there's been a runaway from a cable fracture, and this is the damage that's ensued. Here we see, this is the incline that way, that's the main incline, and this is a route to a quarry where they quarried the stone to build the brake drum house. You can still see the sleeper marks, and actually I mentioned about diverting wagons, runaway wagons. If they were quick, they could divert some of the wagons into the hillside, and then they'd just simply roll back. But if they passed this point, it was a case of, there were areas where they could just simply, it was better to launch them into space down here than let them crash right down to the bottom, and they were a total loss. This is a quarry where they quarried the sandstone to build the brake drum houses. The Victorians were great at utilising whatever was in the area. They didn't transport it from the Dales or Scotland or wherever. They looked for the materials on site or close to site. And this is where they found suitable sandstone, freestone, for building the brake drum house. This is a photograph taken around about 1938 of the remains. It's useful because it shows you the actual block construction. That was photograph taken in 1938. In 1941, and I have a witness for this, 1941, the Royal Engineers blew it up on the grounds that it formed a navigation point for German bombers coming to attack Teesside. Well, they didn't need that as a navigation point. They got the whole of the Tees estuary. I think the Royal Engineers were just looking for something to play with, to practice their demolition. Anyway, it got blown up in 1941. Here we see another shot of they call them kits, we call them humps. You can see the acute angle change, that it was very severe. It was about 30 degrees, which is a very severe angle change. And here we see what it looks like today. And we see a crank. It's probably one of the brake cranks for the brake drums here, lying around. Now, at this point, back in 2004, my wife and I were just having a coffee break. It was a crisp February day, there'd been a frost, crisp bright day, and we were sat at the top just having a coffee break. And I was idly looking at these stones, and what took my interest was the cutout there, clearly fashioned by the masons as a specific fit. And I looked a bit closer, and I saw there was a Roman numeral, 9. And here we have 7, Roman numeral for 7. And here we have 13. And I realised that The stonemasons at the quarry were cutting these stones out, and they had a plan. And it was a Lego. It was a giant Lego. And when they brought these stones to the build site, the brake drum site, they knew exactly where they were going. They weren't just trying them, they were actually made to fit. And they had a specific position, location on the thing. And there they are, they're all numbered. I mean, this is the sort of thinking that went on. You know, we think we're bright these days and we're advanced, but, you know, these people were quite smart. Anyway, we're off. We're finally on top of the moor, and again, you can see 1,370 feet above sea level. How exposed is this? And this was a type of terrain that people were using as a daily communication link, on foot, by horse, or whatever. All weathers, rain, snow, hail and blow. Cuttings were a big problem for the Rosedale Railway. There were snow traps. And when you got a cutting like this, when winter came, it was a continual headache. And this was the sort of problem that they had. You know, again, it's the same story. If the locomotives are blocked, then the mines can't keep producing. They have a limited storage capacity, and then obviously miners become unemployed. And it's the worst time of the year. I mean, winter time, who wants to be, you know, without pay and food and heat and goodness knows what. They did have snowplows, and these were two that were built specially for the Rosedale Railway. They were two-axle affairs, a four-wheel snowplow. And the reason for that, normally these snowplows were a three-axle, a six-wheeler, but because of the severe angle change at the top of the incline, if a six-wheeler was brought up, or a three-axle snowplow, it would cantilever on the centre wheels. So when it came up the incline, when it got to that point there, it would start cantilevering. It would be a real headache for them to bring it up onto the moor. So they designed the two-wheelers, which meant that way they would perform without cantilevering. And so these were two that were specifically designed for the Rosedale Railway. Now this is a three-axle affair, and this was at Newbridge Yard on the North Yorkshire Moors Railway. Since I took that photograph, that snowplow has been away and been completely refurbished. I haven't seen it since its refurbishment, but you know, it'll be impressive. They are impressive. They contain a cabin, and there's a stove in there. So when the train with the snowplow was travelling along the line, the snowplow team were cabined up in there. They had a stove and supplies and everything, and all the tools were in these boxes here, these cupboards. But once they got to the scene of operations, of course, they had to bail out, because the danger was, once they ploughed into the snow drift, then of course they were sealed. They couldn't open the doors. They'd be sealed in their cabin, and so before they actually started to plough, they had to come out and stand by while the locomotive drove into the drift. This is a very early photograph of a snowplow train in operation, and you notice there are three locomotives, snowplow back and front. They had to have a snowplow back and front because the danger was, with the winds up there and the tough conditions, as they drove into a snowdrift and cleared the line in front of them, it was filling in at the back. So they had to have a snowplow fitted to the back so they could shunt out again and clear the way back out. Now we know this is a very early photograph because there are three locomotives, and they found that it was too powerful a combination, and often they get derailments of the snowplow. So they actually reduced to just two. It became the standard combination, 2 locomotives and 2 snowplows, one at the front, one at the back. But the third locomotive was done away with. We're on the route now, and we see that the lightweight walk here is crossing up. This is a lightweight walk, crosses over. It uses part of the railway route, and then it branches off towards the line in at Blakely. And we've arrived at what was probably the loneliest, bleakest crossing gatekeeper's cottage ever. This is the highway up from Kirby Moorside of Ramsdale. This is the Rutland route, and this is, of course, the railway track, and this was a busy track. So they had to have crossing gates. Now, they didn't have any fences at all across here, so it looked totally incongruous that you've got open fields, or more rather, and at this point here, you've got fences and crossing gates, you know, but it simply had to be to control the traffic, the pedestrian and horse-drawn traffic coming up and using this route here, which was a busy route, despite its bleak location. And finally, there's a sign here that marks the route to Stokesley. It's spelt Stocksley, and at the top here there's a removable stone at the top of the post. The idea was you lifted the stone off and threw a coin in for poor wayfarers. So that was a regular sort of feature of these sort of old markers, stone markers. And when I looked in, there were about there was Fortons in, I think, or something. Anyway, so we've actually reached the end of part 1.